Do you feel the vibes?
So let's go ahead and start solving rational functions. The best way is to multiply each term in the equation by the LCD of all the terms. Okay? So, right. So for this one, now what you also want to do, right, is first you want to write down the restrictions, right? So for this one, x cannot be 6. So when it says state any restrictions, that's what it is. X can't be 6. Now, the LCD here, this one has a denominator of 1. This one has a denominator of x minus 6. So the LCD is x minus 6. You have to multiply every single term by x minus 6. Even the 0, right? All of them. Okay? So now what I get is x times x minus 6. That's x squared minus 6x. Minus, this goes away, so 4 is equal to 0. Next, you just need to solve this, right? Well, this can't be factored, so quadratic formula it is. So x equals 6 plus or minus the square root of 36 minus 4 times negative 4 all over 2. So this is 6 plus or minus the square root of 52 over 2. But that is 6 plus or minus 2 root 13 over 2. So finally, 3 plus or minus root 13. And because the only thing that is not in the domain is is 6, none of these answers are 6, you're good to go. Right? So that's it. It's really like this one, like we did this in algebra 2, right? Yeah. Nothing new here. Okay. This one here, we're going to factor this first. So we're going to get x minus 6, x plus 3. So x can't be 6 and x can't be negative 3. So let's multiply by the LCD. It's x minus 6, x plus 3. X minus 6, x plus 3. And same thing here. The point is, if you do this correctly, your denominators should disappear, right? So here I have 2x, x minus 6, plus 3x plus 3 equals 27. So 2x squared minus 12x plus 3x plus 9 is equal to 27. So 2x squared minus 9x minus 18 is equal to 0. Minus 19x. No, minus 9x. Right? Okay, somebody factor that for me.
Negative 6, negative 3. Oh, wait, no, never mind.
Positive 3, negative 6. Okay, so from here, x equals negative 3 over 2. From here, x equals 6, but x can't equal 6, so it's just negative 3 over 2. That's it. There isn't much excitement to this. The inequalities, the rational inequalities, those are more exciting. That's next lesson. Okay. Okay, so the lens equation is this. Huh? No. The lens equation is this. This is, okay, 1 over f, 1 over di, 1 over do. F is the focal length. Di is the distance from the lens to the image. Get it? I for image. Do is the distance from the lens to the object. O for object. So even like when you go to the doctor, you know, like or the optometrist, and they check, right? And you, like, if you need glasses, that means, you know, these distances aren't Like the lens isn't exactly where it should be. And it's literally this equation that they use actually to calculate your prescription. It is not a very complicated thing at all. Okay? So suppose the image is 10. So is 10 centimeters from the lens, which means DI is 10 centimeters. And the focal length is 6 centimeters. So F is 6 centimeters. Write a rational equation to model the situation. So, okay, so we get 1 over F is equal to 1 over DI plus 1 over DO. So this is going to be 1 over 6 is equal to 1 over 10 plus 1 over DO. This is it. This is not a very complicated problem at all. The only reason it's here is so, you get used to sifting through lots of English words, diagrams, and then just coming up with what is asked of you, right? So just like come up with what you have, what you need. Sometimes it's a very simple thing, okay? Now find the distance from the lens to the object, so we need to find DO. Well, if I rewrite this equation, what is the LCD here? Yeah, or you can reduce it to 30. 30 DO. No? Or you could do 60 and then you just need to cancel some things. So this will be what? 5 DO is equal to 3 DO plus what? 30? So 2 DO is equal to 30. DO is 15. So that's 15 centimeters. Isn't that cool? Say yes. Yeah, very cool. Okay, so that's that for this lesson. Now, let's move on. Let's move on to the next item on the agenda.
Press start.